Hello and welcome back to my channel. In this video I'm going to talk again about electronics, and the main goal is going to be talking about IoT and MQTT. So that's some new stuff in the model railroad business that could be implemented on your layouts and stuff. So just to give a bit of a recap, trains there in the model trains, what happens is they use DCC. Like, we went from DC layouts to DCC. So basically, from what you know about that, is that there's a decoder inside the locomotive that receives commands from the command station. And you can put multiple locomotives on the track, but they won't run into each other because each one has its own address and the response to the command station. That on the throttle, you would pick the address of the locomotive you want, and you run that train, and it would go around the track. So that's a decoder for the locomotives. Then you have decoders for the turnouts. So what happens is each one of the turnouts on the layout would have an address, and you would say throw or close, and that information again is sent from the command station. So basically, you have around the layout you have a DCC bus. So you have two wires that go all around the layout that connects to your all the tracks, and the decoders for the turnout decoders, they're connected to the coil or the whatever, if you're using the Pico coils or if you're using the tortoise motors. It goes to the decoder, then from the decoder the two wires go back to your DCC bus, which is basically the track. So all the information is being sent on the track, and the voltage to run the train, and the DCC signal, and that's how everything communicates. They all listen to see if you're talking to it. But one of the things with and that works pretty fine. That works great. But the drawback is that there's no actual feedback from the locomotive or from the train coming back to the command station to tell it what's happening on your layout. So but one of the things is with the ESU lock sound and lock pilot decoders and some of the ZMO decoders, they have it's been a while implemented for a while, called RailCom, and then I think ESU has RailCom Advanced or RailCom Plus, yeah. And what that does is the command station sends your DCC signal, but then there's a little break into the signal that it waits for a reply from the decoder. If it gets some information, then it'll send that to the command station, and then it continues with the DCC. So there's a little interruption, but you don't notice it, it doesn't affect you. But the problem is that, or the issue is that your command station has to support that, it has to be RailCom aware, let's say, that terminology. If it doesn't, then even though you have some lock pilot or lock sound or ZMO decoders that support RailCom, even though the locomotive could be sending that information, as locomotive address with lights are turned on and maybe the direction and such, that information, it's being sent out. But if your command station doesn't, again, support that RailCom, you won't be able to do anything with that information through JMRI or, let's say, train controller software or something like that. So but if your command station does support it, you'll get that information. So that's one way of getting that information feedback from the locomotive. But the turnout decoders or signal decoders, they don't have any RailCom. They're not RailCom aware, so they can't send any information to tell you, yes, that turnout was switched, or yes, that light is green, or whatever. So so there's a drawback there. So now what happens is the next step would be, which is Digitrax. They use their LocoNet, and the LocoNet is a separate bus using a telephone type jack. And what happens is now you have those devices, and they are bi-directional, so they'll send information back and forth to all across. Again, just like DCC sends it on the bus, well, the LocoNet bus sends its information on the LocoNet bus. Everybody listens, but everybody can also give feedback to their position or what's going on. So in the case of my panels here, you see I had built this one. There's a LocoNet connection over here, and this is just power. And so what happens is they're lighted. So as I press the buttons, what happens is this LocoNet device, so only this tiny little wire here, goes to the layout, goes to the turnout decoders, which are LocoNet turnout decoders, and it triggers the turnouts. And then also I have some signals, like you can see over here. These are but these are DCC signals. These are not so they don't give any feedback. but the turnout decoders give feedback, and the block occupancy gives feedback. So based on whether or not the block is occupied, well then, and then you select the turnout, well the light, now the system will also issue not only a LocoNet command but a DCC command to turn the DCC light red, yellow, or green. So each one of those lights has, like I said, they have addresses. They're DCC aware, so they have a DCC addresses, and that's how they'll respond. So the thing is also with this panel is, like, since I have another panel like this one, similar to this one on the other side of the layout, which has switches for selecting the routes and has green LEDs to tell you basically the same as what this guy is doing, but it tells you the route that the locomotive has taken. What happens is when you press a button on one layout, like you see in this case, let's say I'll select route A, B, C, D. So when I go, I'll press D here, and you see the D light comes up on this guy. And the other panel adjusts, and the other. So what happens is not only is it sending information to the layout, but all the other panels are also listening in, and they're reacting. So there's some bi-directional communication going on there. So that's pretty interesting. And again, all the wiring is reduced to just a LocoNet connection like this on a panel, instead of having tons of wires going to the layout and back. So you got that. And now the other way of so you have the LocoNet connection, LocoNet feedback, and then there was also a technology that was around for like 15 years or so, maybe longer, called S88, and that's another feedback type of protocol, but it's not as advanced as the LocoNet. But you can actually build circuits for your layout, and they cost $5–10 in the block occupancy, and it'll tell you where the train information, the trains are on the track and stuff like that. But anyway, it has a few little disadvantages. So moving on, so the next thing I'm going to talk about is this little board that I installed here, and this is like an Arduino type chip board, and that little silver circle, that's a Wi-Fi connection. So and on this board you can actually put like web pages. So this is a power supply. This is just the power coming in. You could use this, like for now it's the power, but you do program this guy. It's like a little computer, and you plug it into your computer with this micro USB connection, and you put the software on it, and away you go. It could run. So the way I have it here is I'm just using this cable for power because it's 3.3 volts, and then I have a little board here, which is what they call a comparator. So it listens for signals on the LocoNet, which is this wire. Okay, this wire is actually a phone connection type wire. And it plugs into the LocoNet, so that LocoNet wire comes here, goes to this little chip, then that information transmitting, so there's an in and an out, so again bi-directional. And what happens is as I press, you see I'm going to occupy the track with a wet finger, so there's some resistance there. So what you see here on this panel, you'll see the red lights come on. That's the route that I'm selecting. So that LocoNet information is being fed back to this panel, to all the panels. So anybody who needs that information, gets that information, and their lights come on and such, and does whatever it has to do. But also the information is going to this guy. So what happens is now this guy has that information. Since it's a Wi-Fi chip, you can send it to through a Wi-Fi, which ends up connecting, let's say, to your router, and then your laptop. You can be running some software that listens in. So now it's starting to get a little bit complicated. So what happens is, and then your PC could send, through the software, could send information back to this device. Now, it acts, let's say, similar to the USB. The LocoNet has a USB LocoNet buffer, and that's where you connect the. I have a little one here. I'm actually, you see this type here? Can you see it? Yeah. Let's see this guy. RC circuit. So that's a USB connection in the front, and then from the back I'll just plug in a wire to the LocoNet, and then you connect to your computer using that device. But this device, it's done through Wi-Fi, so which is great. It becomes like wireless. So you could connect it and use it somehow if you wanted to replace the USB device. You could use that guy. But what's nice about that guy is the technology that or the software that's being used on that is called the MQTT. And so I'll talk about that for a little bit. The other thing I wanted to talk about was Internet of Things. You probably heard the technology or the term Internet of Things. And that's very popular now in home automation. So basically you buy some kind of hardware, and these devices are, let's say, they call them smart devices, and they end up connecting through Wi-Fi. These devices will make themselves available. So it's almost like a LocoNet traffic, but you know how LocoNet uses a wire, this uses Wi-Fi. So it can connect your devices. Let's say you have a Wi-Fi, a little device like that. You end up making a decoder, and let's say when I press switches, I can have input switches. That when I press the switches, this sends some Wi-Fi information. Say yes, this switch such and such was pressed. And now that your computer or the hardware or whatever, that command station, let's say for your home automation, will say, oh, okay, yeah, the door is unlocked, the sensor was tripped, the light, you want me to turn the light on, I'll do all of that. So that whole way that communication is being sent back and forth is MQTT, which is message queuing, message queuing, transport, something. I'll have to check it out later, sorry, because I'm new to this. So then all that stuff, communication is being done around your house, wirelessly. So what happens is, since that's all available, it's becoming popular in the home automation business or domain. One guy on the internet I found, I'll put a link in the comments below. His site is IOTT, so he calls it Internet of Toy Trains, and what he's doing is creating this with this piece of hardware that you saw here, which is a LocoNet to MQTT Gateway. So now what happens is all the information on the layout, as you can see, these panels, like I said, they talk to each other through the LocoNet and all of that stuff. But now this hardware ends up putting your LocoNet information available to IOTT, to like other devices that I'll talk a little bit more about that later. But some of the things are like, let's say you can have that when the track gets occupied, this sends you can tell it to basically send a message. You tell it, listen for that information. If that information happens, if a turnout gets switched or whatever, send out a Twitter. Send out a Twitter message saying that something happened, or send an email, or so it becomes like a weird combination of all kinds of stuff. You can have a device, IOTT device, over the internet in somebody else's house, and let's say a screen or whatever, and then you could have something that if a train is coming into a station on the track and the block gets occupied, which is, let's say, a station track, you can have some another MQTT device or Internet of Things device that's going to have a screen that's going to say, it's going to tell you, oh, train approaching station Fremont Station, or train left Fremont Station. So all kinds of crazy stuff. So it ends up by having an interface like that, you're connecting your layout to outside hardware. And again, you can even have to a point there where a light in your house turns on, or the door unlocks, or whatever crazy stuff you want. All this stuff becomes interfaced with your layout. So that opens up a lot of possibilities. And then the other thing is, on the screen when you do the programming, there's a software, I'll talk about it later, also called Node RED, which is a graphical visualization. So what happens is you would create like these, you have these little blocks, and you say, okay, this is a turnout, this is a turnout. So what you start doing is dropping blocks onto the screen. I'll show you in a second here. Hopefully this is clear enough. So what happens is this is on a web page, and it's running the this MQTT. Well, it's actually okay. The MQTT is the technology that's going back and forth. But then to talk to it, you want to have a nice graphical interface, and that graphical interface is called Node RED. So if you check on Google and you look at MQTT and Node RED, you'll start to get familiarize yourself with all the different stuff that these things do. So in this case, what happens is I'm telling it this is LNIN. So this is LocoNet in, and this is LocoNet out down here, and it's getting information. It's logging information. There's in this example, I have a start/stop button, and what happens is this is the debug mode. See, so what happens is you can end up seeing LocoNet messages here appear. Let's see if that's going to clear up a bit. So what I'm going to do is reach over to my layout and put a wet finger on one of the blocks, and you see a bunch of stuff scrolled there. See, I touch it again, a bunch of stuff. So this is LocoNet information. So this stuff doesn't know, this software doesn't know what LocoNet information is. But you can create, like you can see here, these boxes and stuff, and you end up actually creating some information where you put in. Gets complicated. Sorry about it, but basically what happens is you start to put in a logic that tells it, okay, when I get a code, because there is a standard to the LocoNet, right? There's certain numbers mean certain things to happen. For us, we see digits, we don't know what's going on, but for the computer, it sees this string of numbers and it knows, okay, that's a decoder, 25, and it's set to throw. So what happens is you can end up creating these boxes where it'll interpret that information and it'll say, yes, okay, I want that turnout swished or so forth. So all this stuff ends up being connected. So you can basically connect. In the future, I'll have some videos where it's like we'll have like each one of these boxes, let's say, will be turnout decoders, and then you'll have a bunch of boxes that will be block detection, and then another bunch of boxes that will be signals, and each one will have a number. And then what you do is you connect, like in this case, let's say you put a box here, you put a box there, let's say another box here, and these might be let's say signal decoders. And then you're gonna say, okay, when I press a turnout, let me see. Oops, I guess I should have put a. See, one is an in, and one is, I should have put these ones, these are outs. See, there's a little dot there. So basically you say, I'll connect this guy to that, and this guy to that, and then you do what they call deploy up here in the corner. You say, okay, well, basically you say run that. So what happens is when a condition happens, let's say a turnout is switched, then you want this light to turn, and you'll give it instructions. I want you to turn red, and I want you to turn green, and you'll name all this stuff. And anyway, it'll all come together. And what I was saying before is that it's a graphical interface to tell you how visually you're getting your stuff to work. Because when you use programs like JMRI and stuff, that gets a little bit complicated, or just codes, and you're just putting numbers and stuff. It's like you can get a lot lost. So in this case, it's like no, it's well, I mean, it is. Once you get the learning curve, you start to understand it, then it becomes a lot easier because you're having visual representations of your turnouts and signals and all of that stuff. So that's what's going on with that. So I think I've covered a lot of stuff for now, and I'll give an update a little later on. Thanks for listening. Bye bye. The other thing I wanted to point out was you can see down here I actually have this is a Raspberry Pi W, which is a tiny little computer. You can run JMRI on it if you connect a monitor to it, but I'm running it headless, so I just have it plugged into the wall there. And since it's a W, which is Wi-Fi, so it's got the Wi-Fi connection built in, so from my computer I can talk to this device. So I'll show you an example. Let's head over to the computer. Okay, you see that you use a program. It's called PuTTY, and basically you connect to. So it's a window that you connect to through your LocoNet. Wi-Fi connection. You connect. So this is running the software, this Node RED software that we saw over here. It's running the Node RED, and it's running what I was saying before. It's called the MQTT software, which is the communications back and forth between those hard IoT devices. So no screen attached to the Raspberry Pi. Like I said, boot it up, it runs the two services in the background. So now what happens is, like you can see, it's within here connected, and so now the Raspberry Pi is getting all the information. And again, with, like I said before, through the graphical interface, you're telling it what to do with that information. And since it's all Wi-Fi and such, like I said, you can see these are some examples. Let me go down here. See, GPIO pins, which are people familiar with on the Raspberry Pi. You can have something that's built onto the Raspberry Pi to happen when a certain condition on your layout is happening. And then you can go into real crazy stuff like, let me see, Twitter. See, there's a Twitter. You can send out a Twitter. You can send out an email. Google Plus, Google Places, Google Calendar. You can actually put something in a calendar. Let me see. Raspberry Pi, mouse, big timer, read events. A whole list of stuff. SQL database, you can have Google Geo coding directions. Arduino stuff could happen. Google Calendar. So basically, people write like these little programs here. You could have something on your layout that if the weather outside or if it's nighttime or whatever, you could have mood lighting, happen on your layout based on other stuff that's happening. It's like crazy stuff. Imagine you have a water detector, right? Like a weather machine outside, something that detects the humidity in the water or whatever. And if that is triggered, that tells this, again, IoTT, so all this Internet of Things, all that device tells your network, hey, it's raining outside. So if it's raining outside, then simulate some rain on a piece of hardware that I have on my layout that it's raining, or if it's snowing outside, or if it's cold or whatever, blow some wind or sound stuff. So it becomes all kinds of crazy stuff that this allows you to interface to your layout using that small little board that you saw. In my case, I'm using that board, which is like, let's say, a $5 board with a couple little pieces. So at the end of the day, I think it's maybe tops $10 worth of parts. And then you get yourself a Raspberry Pi W, which is going to run the software. You can run the software on a laptop if you want, but then your laptop has to be on all the time. So putting on a little battery operated or a little wall, again, they take a little power, the Raspberry Pi, so you have that plugged into the wall like I have, discrete, just running in the background, and all this stuff will talk to each other. So it gives up a lot of possibilities. So yeah, that's it for now. Thanks for listening. Bye bye.